Here's an example too about coffee. The coffee machine dispenses about 10 ounces per cup, but it obviously isn't perfect and it varies slightly from cup to cup. So someone measured, randomly chose 20 cups to measure the amount of ounces, the number of ounces that were put of coffee in the cup. And they want to know if the machine is actually shortchanging people. So I've got the data in here, and what you want to do, eventually you're going to want to use your stat edit function and put all this data, and I put it into L1, and we've talked about this in other videos way past, so you should be familiar with that. But before we do that, we need to do some assumptions and conditions here. And so let's go through that. So we want to check independence first. Okay, I want to check independence. And the way I'm going to do that, it says 1 cup doesn't affect the amount in another cup, especially randomly chosen cups. Okay, and you know, as I mentioned randomly here, so I've already checked the condition of randomization. It mentioned that it's random. If we go back a screen, it says here from a random sample here. So we've got that checked as well. So the other thing is we'll check the 10% condition, which helps with it as well. And we're going to have to assume that there's greater than or equal to 200 cups that are dispensed. That's like saying the population is greater than 200 cups. Okay, so that's fair, and that seems like a reasonable assumption. Okay. Then the part that is going to be harder is it normal? Do we have at least a normal looking thing? So we're going to have to check the histogram for it. And remember, we already put the data into L1, so we can do that. And then to do that, remember, we want to go stat plot, and we want to turn on. You want to turn it on. And then you want to choose the one that looks like this. Looks like a histogram. Like that. And our data, our X list, is L1. And our frequency, you probably don't have to change, is 1. Because we have one piece of data for each cell. We don't have... Okay. So that's fine. We've got all that there. So we're going to look at how normal does it look. And so... once you get all that done and you press, if you do zoom and choose number 9, it will make a histogram for you. Now it won't choose the nicest looking numbers, but what you want to do is you want to have a sketch of it. And if you do the sketch, what you want to do is make sure that it's you're going to use the trace key to do that. So I'm going to pause here. I'm going to finish the sketch. I'm going to use the trace key to get all the values in here. It turns out it looks, I haven't drawn it yet, but it looks unimodal and fairly symmetric, so we're in good shape. That's what we're looking for. So this is what we're looking for when we do it. And because of that, we're going to say it's approximately normal. So it seems normal enough. Okay? So we'll be in good shape there. But I'll quickly sketch it here. Okay, so like I said, this looks symmetric and unimodal. If you look at here, and you notice I put the frequency, I ran out of space, so I put it here. There's the frequency in cups. Here is the ounces. and you can see me, every other one is trying to listing down here, and it's a real quick sketch. If you're on the AP test, you might want to quickly sketch. You might want to quickly sketch this, and then say it looks symmetric and normal and move on. You don't want to waste too much time, but you want to address that you made a histogram that looks like the histogram looks symmetric and normal, so it seems normal enough. So we're going to do. They asked us to test it. So if you go back here, they said, is there evidence that the machine is shortchanging customers? They're asking for some kind of test. Test it, is what they're saying here. So what I'm going to do, okay, so since the conditions are met, we're going to do a t-test. Remember, it's not a z-test because we're dealing with means, and we only have the sample here. Now, I started, to save time, I wrote down some stuff. I went to one variable stats, so I pressed stat, one variable stat, enter. All my data is in L1, and I got these numbers. I got the average. I've got the standard deviation in ounces, and then I wrote the null hypothesis. If the machine is behaving normally, we're going to expect 10 ounces. Now, some people say, is it not giving 10 ounces? Then it would be like this. Okay, but it says, is it short-changing people? If you're short-changing people, you're saying 10 ounces, but it's not 10 ounces. So I went with the less than the one tail test. So I really need to add here one tail. Okay, I really need to add that in that t-test with one tail, but it goes because of the less than and because it said short-changing. Okay, so we've got that there. And so we've got the null hypothesis, we checked it, and the alternate, we've checked it now. What we need to do is get the standard error so we can do a t-score. So we want a standard error, and that's going to be the standard deviation by the square root of n. And it turns out, we had 20 pieces of data. Remember, n equals 20. Okay, so we're going to have 0.1986 divided by 20. Okay, and we get I think I said 20, it's the square root of 20. We get 0.0444. I'm going to leave it like that. Okay? So that's for our sample of 20. That's the standard error. So we should be good with the t-test. Now, remember, we're doing a t-value, and we're going to have a degree. What is our degrees of freedom? We're going to need that. So we have 20 minus 1, which is 19 degrees of freedom when we need it. So I'm going to go, my t-score is going to be, well, we got 9.845 minus 10 divided by 0.0444. So that gives you negative 3.4903 for your t-value. So we should draw a picture to express that. So what we're going to do, okay, again, I'm making it look like that. We think there's 10 ounces on average, but we got it 9.845. Okay, and that gave us a t-score of negative 3.49, I'm just going to say. And we want this area right here. Okay, so that's the area, that's the p-value here. Okay, so how do we get that? Well, remember, on the calculator, we're going to use our second vars, and we're going to go second vars, and we're going to find our TCDF, and we're going to go from our low t-score. Well, we're going to negative infinity, right? So I'm going to say negative 99 to our high t-score, which was negative 3.49. And now we have to put our degrees of freedom in here, because we're doing that particular t-curve. It's different than the normal one, so we're going to put that in. And that gives us, when I do that, okay, so, oh, fantastic, we got a p-value. Now we just have to interpret it. Okay, so you notice here I have my standard. Let's go back through. I have my, I've got my standard error. That's good to have. I've got my t-score. Okay, I've got a picture. I found my p-value, which is right there. Now I just have to interpret it all, so let's go through that. So my interpretation here. Now let's use an alpha equals 0.01. They didn't tell us. So we'll say, since the p-value, I can't spell, since the p-value equals 0.0012, which is less than, less than alpha equal 0.01, is small, reject the null hypothesis. So we're going to reject the null hypothesis. This is strong evidence to suggest the machine dispenses less than 10 ounces, so it short changes people. Okay, so I've done that. Now I'm going to go fast. You can do this. Was done by hand here. If you go to the next screen, I'm just going to quickly walk through the instructions. If you were to do this on the calculator, you've got to put all the data into L1. And after that, you can go to Stat, Test, and do a t-test. And what you're going to do is it's going to ask you, when you do that, it's going to ask you to want data or stats. Well, you have all the data in. So data, or it's going to ask you for stats. You can do either one because you did it. If you do stats, you put the mu in, and if you do, and then you have to put the standard deviation in, which was 0.19 something, and you have to put the x bar in, which was 9 and if I go back a screen, 9.845. Okay, you put those in there yourself, and then you go. Then I would do calculate, gives you all the stuff, or you can do, and then it also says draw. And I would do both. You have to do one, and then you have to go back to stats and do draw, because this gives you your drawing like we had. That was down here. And this one gives you your p-value, and it gives you, so that's one way to do it with stats. If you do data, it's going to ask you, so I'm just getting to it so I can just make sure I don't miss anything. If you do data, you have all the data. So you're still going to have to put mu equals 10, but it's going to ask you a list. Well, we had all the data in L1. And so when you go down to calculate, and you always have to choose, you're doing that, we were saying our null was that mu is less than 10, excuse me. So we're going to have, in our case, we're going to say less than mu 0. Well, mu 0, remember, was the 10. Okay, so that's what you're going to choose on this one because we're doing one tail. So mu 0 is the null hypothesis. Our null hypothesis was this. So we're going to choose that one in both cases. And when I go down here, it's going to give me the same thing. It's going to give me a p-value. Okay, this is your p-value, and which was 0.001 something. Okay, it will also calculate what we calculated by hand, which was, it gave us t negative 3.49. It gave us x bar, which is 9.845, and it gave us a standard deviation, which is 0.1986. It gives these numbers, which we calculated by hand. It does it all. So you may want to, for time's sake, do this stat tests, because especially if you have all the data in, it does everything for you, even drawing it, because you can do a draw and you can do the calculate. Now if they give you a problem with these in it, then you just go over to stats. Instead of data, you go over to stats and enter these numbers in. But either case, there's some overlap here. This part here you have to set up yourself and you have to interpret. Okay, now it seems to take about 16 minutes. It's more about 20 minutes if you really know what you're doing.